Welcome to the screencast regarding our project. We, that is Imran, Bansi and Christian, have set up a small cloud storage application using the OpenStack private cloud available in the NetLab. Let's walk you through the most important aspects of our project. First, we are going to take a closer look at the concept. After that, I'll explain the architecture of the infrastructure we have set up. Then we'll look into the initialization process of the required components, and then we will talk about the required autoscaling aspect of our infrastructure. We'll then have a short talk about how to improve the architecture of our project if we were to continue it in the future. We'll end the screencast with a short live demo showing the deployment process and the setup OwnCloud instance. Unfortunately, due to an existing error in the OpenStack environment, we won't be able to demonstrate the scale-out part. Let's start with the concept of our project. We decided to deploy a web application providing storage to our users. We use the application OwnCloud as the web frontend. We have multiple instances running OwnCloud pooled together, which are automatically scaled out if necessary. To distribute the load evenly across all OwnCloud instances, we use a load balancer. All instances use a shared file server and a database to store the user content and OwnCloud data like, for example, user profiles. Let's take a quick look at our architecture diagram. At the top, you can see the load balancer used to distribute our users evenly across all the available OwnCloud instances. It uses a HA proxy installation. The pooled instances are shown below. To make sure users can correctly maintain their session, with an OwnCloud instance, we use an additional session manager running a Redis installation. The whole pool has access to one shared database running MySQL and also one shared file server running Samba. This can obviously become a serious bottleneck in a real use case, but it is perfectly fine for this small project. All instances are OpenStack Nova instances running on a Ubuntu 18.04 OS, and the instances are flavored as M1 small. Apart from the autoscaling OwnCloud instances, which are deployed using an OpenStack Heat template, all other instances are initially deployed via Python scripts using libcloud. To initialize the setup, we run the scripts and the template in the following order. First, we start a database. Then, we have to start a file server. After that, we start our Redis server. To be honest, the execution order of these three does not really matter, because they do not rely on each other. The OwnCloud instances, however, do need at least the database and the file server to work correctly. The load balancer needs to be deployed last, because it needs to collect all the IP addresses of the running OwnCloud instances for it to work. This actually holds a tiny issue, which we will talk about later on. Using the Python scripts, we can essentially leverage on-demand self-service to deploy our infrastructure as code whenever we need it to. The autoscaling of the OwnCloud instances uses an OpenStack Heat template to be defined. It contains a scale-out policy which will add one instance to the pool whenever an alarm is triggered by lasting high CPU utilization of one of the existing instances. On the other hand, a scale-in policy will terminate one instance if an alarm is triggered by lasting low CPU utilization. Thanks to the autoscaling, we can also leverage the benefits of on-demand self-service, rapid elasticity, and of course the measured service. That way, we would never have more instances running for OwnCloud than necessary. To conclude our short presentation, we will now take a look at how we could improve on our project in the future. As I mentioned before, using a single session manager, database and file server could provide a serious bottleneck and availability threat in a live scenario. To reduce the setup effort even more and become more fault tolerant, we would need to introduce load balanced clusters of these instances as well. Also, we could definitely improve our existing load balancer by, for example, using OpenStack's Octavia's load balancer as a service, which could provide very easily a pool which automatically recognizes new instances being added to the OwnCloud instance pool. The current load balancer does not do that, and either needs to be redeployed or updated to achieve that. These are the references used for our setup, and now we will show you a short demo. Okay, before we actually get to the live demo, I would like to walk you through example scripts showing what we did use to initialize our environment, which would be obviously the Python scripts represented by Redis PI in this case, which is running a libcloud script. And then we have our shell script, which would be used within the Python script to actually configure what's happening on the instance itself. And then we would have the OwnCloud instances YAML file, which is a OpenStack heat template to deploy our OwnCloud cluster, especially containing the autoscaling part. But we will start with the Redis PI, which is, as I said, the file to deploy the Redis server. You probably recognize this file because it is based on a working example from the course, from the lab sessions. So we took that, kept some utilities and modified it to serve our course basically. So we just pass all the parameters that are needed, which would also be needed for a manual deployment using the web interface. Then we would create obviously the connection and get the image, flavor and network before creating then our key pair dependency, cleaning up previously used installations if existing, and then create the security groups that we need for Redis. In this case would be 22 and 30, no, 6379, the Redis port. Yeah, perfect. And the most important part is down here, where we basically just pass the script as a link, the bash script redis sh as a link to the Redis instance when it's booting up as user data Redis. So this would get executed as soon as the instance is ready, and therefore also execute the bash script, which is shown here. Small bash script in this case, which will just edit some configuration files and restart the Redis servers afterwards. Obviously, you would have to install it first, but yeah. So that's basically what happens using Redis and Redis sh together. And then there is the heat template, which might look familiar as well, because that also relies on a working example from the lab sessions. We took that and modified it as well to fit our needs. In this case, we declared all the parameters that would be used and set up in the manual deployment using the web interface as well. And once these are all passed, we get on to define our resources, which would be a security group for the OwnCloud instances, a OwnCloud cloud config in this case, which would do some things like setting the name of the instance, etc., but also running a bash script, which is again used to modify and set up the OwnCloud service itself on the server. Then we would have our autoscale group. This is where things get spicy, because this is then dealing with the autoscaling part. And this autoscale group would obviously rely on so-called policies. We have a scale out policy and a scale in policy. Both will actually wait 60 seconds for a scale out or scale in to happen after one just happened, so that we don't scale out or scale in too quickly. The adjustments are just +1 instance or -1 instance for scale out and scale in. And these policies get actually triggered by the alarms. We have a CPU alarm high and a CPU alarm low, slightly modified from the example. So in our case we would trigger a high alarm if we get over 90% CPU usage over the course of 2 minutes. They have to actually last 2 minutes before this alarm gets triggered. This would then obviously trigger the scale out operation, and then on the other hand we have the CPU alarm low, which would trigger if the CPU is not higher utilized than 10% for 2 minutes in a row, and this would obviously trigger the scale in policy and result in one instance getting removed. Okay, thank you. We will now move on with the live demo. Okay, here we are. This is the previously teased demo which Bansi, Imran and I did record earlier. We would start with the initialization of the whole environment. If you remember correctly, that would be the database first. Nothing special to mention here. We just used a libcloud Python script to deploy the database instance, which shouldn't take too much time. Yeah, and if we take a look now at the instances tab, we should see the database popping up. There it is. Perfect. And then we can already move on with the initialization of the next component, which would be, I guess that was storage. It was. Yeah. Same thing basically, just run the initialization script, and after a minute or even 2 there might be a second instance popping up. Yep. Now we refresh and hopefully there it is. Perfect. So now to number 3, which would be our Redis server, but if you paid close attention to the presentation, you know already that the execution order on these 3 doesn't really matter, because obviously they don't rely on each other and therefore can be executed just in any given order. So this would be a onCloud script as well, a libcloud script, I'm sorry, would be a libcloud script as well, which has to be run. Yep, same procedure, nothing new. And after a while we should see that also the Redis server would be popping up in our instances tab. There it is, ready to go. Oh no, it still needs to spawn. Give it some time, don't be impatient. There it is, perfect. And now things get a bit spicier, because we now can deploy our stack with the predefined onCloud template, which is actually a OpenStack Heat template. This will basically deal with the creation of all instances, of all onCloud instances, and then also define an auto-scaling group, the scaling policy and the mentioned alarms to achieve automatic scaling. Unfortunately, due to the error I mentioned in the presentation, we can't actually demonstrate this scale out in the live demo. Therefore, we just resorted back to initializing our onCloud pool with 2 instances. which would, with a working OpenStack environment, then also scale in and scale out as the CPU utilization would be high or low. They need some time to spawn, and after that we can deploy our last component, which would be the load balancer. This one is not as optimal as we would like it to be, because obviously when we spawn the load balancer with the initialization script, with the Python libcloud script, we cannot know the IP addresses of future instances that would get spawned by the scale-out. So this load balancer only knows the IP addresses, and therefore only load balances the IP addresses that are currently available, which is a bit of a pity. We would like to have a load balancer as a service using OpenStack's Octavia load balancer solution with a automatically adapting pool, but we tried it manually and we tried it automatically, and the pool creation just didn't work. So we had to resort back to that. So that's something we could improve on later. So you might notice a bit of a time skip coming up in a couple of seconds, because the old cloud instances actually need a bit of time to run the initialization scripts and be fully active. So that takes about, I don't know, 10 minutes. So Imran, Bansi and I took a short break and then came back for checking the results, which would be very easy. Just enter the floating IP of our load balancer and you should get redirected to a instance. During the initialization process, we set up some accounts that are usable, and here we are. That's the interface of one on-cloud instance, where we can now store, for example, this beautiful ship picture. Yeah, not much to say. There is a lot of things to do here with on-cloud. You can tag things, you can delete things, you can download things. Yeah, to be quite honest, we spent more time setting it up than actually enjoying our result. Normally you should be able to delete everything, but this on-cloud manual doesn't really want to get deleted. God knows why, but the ship did perfectly fine. Yeah. So yeah, that's basically a working on-cloud instance. Perfectly fine. This concludes our demo. We hope you liked the results and wish you a good day. Thank you.